All right. Good evening to all the grade 12 students. Welcome back to the last session of your aldehydes, ketones, and carboxylic acid. Yes, we have started this session, students, for your board examination preparation. Almost we are on the 23rd day. We have started this aldehydes, ketones, and carboxylic acids with one first video that's nothing but complete concept map, correct? This was including your in line by line NCRT concept map I did in just 5 pages. So completely, if you study those 5 pages, your aldehydes ketones will be over. On day two, what did I do? I did or I started with MCQ series. Along with that, I also did 1 mark questions. I was doing 2 mark questions. So total, how many I said there? 37 questions. So we have completed in that yesterday from 1 to I think 1 to 17. Now we are going to do today remaining questions. All right, with this chapter will be done. And one more important thing I'll be telling you at the end of the video. Stay connected. Let's start. As I said in this particular video, I'm going to cover all these concepts. Yes, with this, as I said, concept map, handwritten notes, and this completely aldehydes will be done. This is a maximum weightage chapter. Remember that. So let's start with the question number 18, where I left. I did 1 to 17 yesterday. Watch that video and come back to this video so that complete aldehydes is done. Let's see the question. Benzaldehyde can be obtained from benzyl chloride. Write reactions for obtaining benzyl chloride and then benzaldehyde from it. Okay, what did they say? Benzaldehyde can be obtained from benzyl chloride, they said. So first of all, I have to take or write the reactions. So, okay, benzaldehyde, what is the formula? What should I get? Okay, I should show them this production. I should show this production, benzaldehyde. Okay, done. Benzaldehyde. Then I also said benzyl, and they also said from benzyl chloride. What is benzyl chloride? Benzene ring is there. Along with that, a CHCl2. This is benzyl chloride. Benzyl chloride. And why are we writing this first? Because in the board exam, even if you don't remember the complete reaction, if you write this to some extent, you'll be getting half mark at least. Okay, students? Chalo. So what is the procedure? So first of all, let us go back reaction. Okay, first, my final product should be benzaldehyde. This is done. So I'm naming the compound also benzaldehyde. Now go back. They said benzaldehyde can be obtained from benzyl chloride. That means one of the reactant is benzyl chloride. This is benzyl chloride. Now you only tell me, students, this benzyl chloride, whatever is there, what are you observing? Yeah, right. There is one chlorine atom attached. So to attach chlorine atom to the basic ring, that is toluene, correct na? The parent atom is toluene. What did we do? To attach this chlorine atom, I have introduced chlorine in the presence of H nu, sunlight. So toluene, this is converted. So one of the particular reactant is conformed. Then I have to get this compound. From here till here, what will you do? You have to introduce this group, right? HO group. So you're going to take an hydronium ion or water. Okay, do take water. All right. Hydrolysis. Then at 373 Kelvin, what will happen? You will remove, when you do this hydrolysis, you will remove this chlorine atom. So how many chlorine atoms? Two chlorine atoms will be removed. And when you remove this, you will be getting a compound which is not stable. This is the compound which you get, the HHO. Now what will we do? You further do hydrolysis to this. You further do hydrolysis to this. So this bond breaks and the compound, what you get, the final compound you get, and this bond, and finally benzaldehyde is formed. Is it easy? Easy. You go back and see, they've asked me all factors. See here. Can be obtained from benzyl chloride? Yes, I showed them. Write the reactions? Yes, I showed them. Obtaining benzyl chloride and then benzaldehyde. So both the things I have shown. So this is the concept, student. Easy? Very easy. Let us see the next question. Yes. Question number 19. Name the electrophile produced in the reaction of benzene with benzol chloride in the presence of anhydrous AlCl3. This is the Lewis or acid which is used. So name the electrophile is what they said. Na? Simple question, but it depends upon how many marks they're giving. So electrophile produced in the reaction of benzene with benzoyl chloride. Shall we take that? All right. So first of all, what is the name of the reaction? Whenever you see anhydrous AlCl3, okay, done. Remember, it is a sort of electrophilic reactions, okay, done. But whether it is acylation or alkylation, how will I know? Yes, it is acylation because you have a benzene ring which is attached. That means, what did they say? First of all, you'll write name of the reaction is name. How did I know this? Because I know there is a benzene ring taken, right? So you'll take write like this and write it is Friedel-Crafts, Friedel-Crafts, Friedel-Crafts acylation reaction. Friedel-Crafts acylation reaction. Then now you have to show the reaction part, right? So let us take. What will I do? I will take benzoyl chloride. Benzoyl is this, chloride is. Now they said in the presence of anhydrous AlCl3, so AlCl3. Now remember students, you are going to write name this compound. This is benzoyl chloride. Okay. When you add this Lewis acid, what will happen? Lewis acid will try to drag the electron density, and how does it form? It's going to form a bond Al C6H5 C double bond O is 1. This she'll get partial positive charge and Cl is attached, and AlCl3, this gets a partial negative charge because this is Lewis acid, right? Yes, so this gets a partial positive. Now positive and negative. Further, you're going to take that AlCl3, whatever, there's a cleavage of the bond, and you get C6H5 here because it is a Lewis acid, the bond breaks here. C6H5 O minus plus AlCl4 minus. Simple. Or here it is minus. This is not minus. This is AlCl4 only, not minus, because this has picked up the minus charge. Now, what is it, students? They have given me complete reaction. Now, in this particular what is the question asked? Name the electrophile. What is electrophile here in this case? Yes, the electrophile is Cl plus, correct? In the reaction of benzene with benzoyl chloride. All right. I have written the reaction. So here, name of the reaction. This is the first one. The electrophile here is Cl plus in the presence of anhydrous AlCl3. Here Cl plus in the presence of anhydrous AlCl. Done. Next question. Oxidation of ketones involves carbon-carbon bond cleavage. Okay. Name the products formed on oxidation of 2,5-dimethyl hexane-3-one. Okay. 2,5-dimethyl hexane-3-one. Okay, first of all, oxidation of ketone involves what? All right, he only gave me the concept. So I'm going to take this compound first. Okay, do I have a page? Yes, I have a page. I'll use this page and this page. First of all, let me write what is 2,5-dimethyl hexane to one. First hexane. 1, 2, 3, 4, 5, 6. This is my CH3, my CH. They said at the second position and the third position there is di. At second position, fifth position there is methyl. Okay, this is second position, second, and fifth. This is fifth. And in the third position there is hexane, and this is CH2. Okay, done. This is the compound. Now what should I do? I have to oxidize. This is your ketone. Involves carbon-carbon double bond. Name the products formed on oxidation of this. So this one should undergo oxidation process. So oxidation process means what, students? You're going to introduce. Okay. So you only see where will the bond cleave. Yes. Because they have given here clue. Oxidation of ketones involves CC bond cleavage. They have given me this. CC bond cleavage. Where will the bond cleave? This is one part where it cleaves. This is one more part where it cleaves. All right. What do you get then? So CC bond cleavage later in the product, we are going to show because they're asking me final compound. So I'm going to first break this bond and take that. What is the first compound form, students? Once I break this, CH3, CH, CH3, COH, because you're doing oxidation, right? So the series of products are formed. Let us write what I get. I'm doing oxidation. So the product formed, one is CH3, H, the CH3, COH. This is one compound. What is this name? This 2-methyl propanoic acid. 2-methyl propanoic acid. Okay, done. Then after that, one more. What is the other one which is formed? Further, suppose this cleavage is over. Now I'm cleaving it here. Suppose if I'm cleaving it here. All right. So take this compound. This part I'm taking. CH3, CH3, and the CH2 is there, right? So I have to write CH also here. Okay. Now I'm going to cleave this part of the compound. What compound I get? I'm going to get H3, CH2, COH. This is over. What is the name of this compound? This 3-methyl butanoic acid. This is also A over butanoic acid. Now, what else will I get? There is one ketonic group here. There's one ketonic group right here, right? So this ketonic group, yeah, also if I consider, I can take this carbon, I can take this carbon, correct now? But here they've given me oxidation of ketone involves CC bond cleavage. Name the product formed an oxidation of this. So this hexanone part, this part I have considered, this part I have considered. There is one more part that is nothing but your propanol, C double bond O. Okay, now you see when I add all this, and so they asked me what are the two name the products formed on oxidation. So I have involved, I have shown the cleavage. Now what acid do we have? We have taken this. So the acid which I get is one is acetic acid, correct? Na? Ethanoic acid. H3COH is one. One is methanoic acid. Ethanoic acid one, and and methanoic acid with and meth. Methanoic acid is, and students done. So you see the compound which acid is formed. Both when I check further, it's going to break up into those fragments and give me. So 3-methyl is over, 2-methyl is over, propan also. Okay, now done. So see the question now, it's done. We've completely broken the bond, formed the products and shown them. Next question, let's see. Arrange the following in the decreasing order of their acidic strength and give reason for your answer. Okay, so the option is not given. So I'll give you a question here by myself so that it is easy. Arrange the following. Suppose if one compound ethanol is given to me. Okay? There is one more compound which is acetic acid. There is one more compound chloroacetic acid. Then there is one more compound, fluoroacetic acid. This is given. Okay. Now understand, first of all, in all the things, whatever you have, okay, acidity, they said. Acidity depends upon two things. What is that? First of all, concept number one is more the electronegative atom, the drag will be more, correct? More the electronegative atom. What will happen? More drag. So, more acidity. It will break the bond and release the proton. Correct, right? That. Second important thing, more electron releasing groups are there, acidity decreases. Correct? No? Because the electron density already is more. What will it release? So, according to this order, what will be the correct option, students? Tell me which will be more and more acidic among everything. Yes, this will get first position. Then this will get second position. Then compare. So basically, then what will I get? Um, Chlorine is over, chlorine is over. Among these two, which is more, which has more alkyl group? One has. This is third, this is fourth. Correct, na? Yes. So what will I get? Write the answer now. I'll go back to show it to you. Okay, then I'll show just. Now let us write the order. First, FCH2COH is more acidic because of more electronegativity. ClCH2COH is the second one. Third, CH3COH is the fourth one. Third one, and H3CH2OH the fourth. And this is more electron releasing, that's why it is less acidic. This is more electronegative, that's why it will drag the electron density and become more and more. Next question. Write the product. What products will be formed in the reaction of propanol with 2-methyl propanol in the presence of sodium hydroxide. Okay, sodium hydroxide, nothing. Aldol condensation is what they're asking me. Okay, write the name of the reaction also. All right. So what did they give me? They've asked me, first of all, what products are formed on the reaction of propanol with 2-methyl propanol. Okay, 2-methyl propanol. Both, okay. Uh, both the things I should write, right? With propanol also I should do, with 2-methyl propanol also I do. Okay, first of all, let me take propanol. Okay, CH3, CH2, CHO. This is propanol. Then I'm going to again add one more mole of propanol. One aldehyde, one carbon, one CH3. I have expanded this. Okay, this is your hydrogen and one more hydrogen. Actually, it is CH2, CH2, right? So I have written two hydrogen. So this is aldehyde group. So this is alpha carbon. Okay, this is your alpha hydrogen. So what will it do? This is going to go and affect, because that is the concept, right? The presence of alpha hydrogen. It is the compound having alpha hydrogen only undergoes aldol condensation. So the compound goes and shifts. Now I'll use, because I have place here, I'll write here. So what will happen when it shifts? I'm writing the whole compound here again. CH3, CH2, CH, OH. Am I clear, students? See here. CH, CH, that H is shifting and OH is down. OH, and you will be getting again CH, H3, HO. What is this compound called? This compound is called 3-hydroxy 2-methyl pentanol. 3-hydroxy 2-methyl pentanol. Correct? Okay. Now what am I doing? I'm going to do, take out water molecule from this, and further when I take out water molecule, what will happen? OH from here, yes, and H from here. Take a different pen so that it is easy. OH from where, students? OH from here, H from here uh, is released out, and your the bond, whatever is there, it's going to shift here. Correct? So what will you get? You're getting H3, H2, CH2, H double bond, C, CH3, and C. Okay, again got the same pen. Okay, red pen. What is the name of this compound? 2-methyl pentanol. That's all. Yes, easy. So now the same thing I have to do with which one? 2-methyl propan 2 propanol. Okay, same concept. You do by yourself and give me the answer, what product you get. CH3, CHO mechanism. I'll just write it and give it to you so that it is easy for you to work on that. This is your CH3, this is your CHO. Step number 1, this is going to go attack, same procedure. After that, you'll be getting one compound, is aldol. Okay, name this compound. What aldol? That aldol, that particular aldol, again you're heating it, removing water, you'll be getting a compound which is enol. Correct, right? So the second compound will be aldol, the third compound will be enol. Will you tell me the answer in the comment section, students? The correct answer, whatever whoever gives me, I'll be pinning their answer in the comment section. Whoever gives me the answer, that particular answer will be pinned in World of Chemistry. Got it, students? All right. So the same procedure, work on that and tell me. Chalo, question. This is a very big question, students. Let us read. It is nothing but case-based question. Let's read. Compound A was prepared by oxidation of compound B with alkaline KMnO. Okay. Compound A, on reduction with lithium aluminum hydride, gets converted back to compound B. Alright. When compound A is heated with compound B in the presence of sulfuric acid, it produces fruity smell of compound C. Which family does compound A, B, C belong to? Oh, big question. Let us start understanding. First of all, what clues are given? See here. Compound A was prepared by oxidation of compound B. All right. part 2 with KMnO4, an oxidizing agent. Then again they said compound A on reduction with lithium aluminum hydride gets converted back to B. This is the clue we have. Okay, back to compound B. This is the clue, students. Remember, careful, A to B, B to A. First of all, A compound is an acid. What is it? It is a carboxylic acid. Carboxylic acid. How did you know? I'll tell you. B is an alcohol. Alcohol. And one more clue they gave me. And see here. In the presence of sulfuric acid, it finally produces fruity smell of compound C. Okay. Compound C is showing fruity smell means it is nothing but ester molecule. Perfect. Ma'am, how did you do? Just see. All I know one thing, that is alcohols on oxidation gives me acids. Aldehydes and then acids. Correct? Then acids, when you are using your reducing agent like lithium aluminum hydride, here KMnO4, you will get again your alcohols. This alcohol. Now see, students. So basically acid is A, alcohol is, this is also B. Okay. One more thing they said, when A and B combine together, correct na? When A is heated with compound B, so this A, that is A by B, when you're heating with your sulfuric acid, which reaction is that? It is esterification reaction. Esterification reaction. You get compound C, that is nothing but C, is an ester. Easy? Let us do the reaction now. So there's no place for me. Oh, very bad. There's no place left. I should scold my listen editing team who has done this. Sure, I'll make it for you here, student. Here. First, CH2H, KMnO4. This oxidation. This RCOOH. This A. B. Now, this particular thing, carboxylic acid. When I use lithium aluminum hydride, I get alcohol back. Alcohol back. A and B. What is A now? It is RCOOH. What is B now? RCH2OH. What is removed? Water is removed. Presence of what? Sulfuric acid. What will I get? Ester. RCOOCH2R. My ester. Compound C. Got it? Yes. So this is your particular paragraph based reaction, students. Let us see the next question. Okay, shall we go and write here? Go and write here only. What was A? This acid. What was B? This alcohol. What was C? C was that's easy. Question. Arrange the following in the decreasing order of their acidic strength and give example of for the arrangement. This is the particular thing. Okay. Just now I said no, acidity increases as electron withdrawing group increases. Second point, acidity decreases as electron releasing group increases. You only tell me among all which is more electron withdrawing, this gets the first prize. Then comes second prize. Then comes third prize. So what is the order, students? The solution is NO2, CH2, COH, more acidic than FCOH, more acidic than CH5. So now what is the concept in this? NO2 and F are electron withdrawing groups. Among both, this is more electron withdrawing, correct? And in case of C6H5 group, this is electron releasing group. That's why acidity increases, acidity decreases. Concept. Next question. Alkenes C double bond C and carbonyl compounds C double bond O both contain a double bond. Okay, but alkenes show electrophilic addition reactions, whereas carbonyl compounds show nucleophilic addition reactions. Explain. Okay, so first of all, please try to clearly understand. This is alkene and this is carbonyl compound. Let us first clearly understand both. I'm starting with how many pages do I have? I have only one page. Very bad. So I'm going to use this page also. First of all, the carbonyl compound, the carbonyl group rather, what is the speciality? This is more electronegative and this is electropositive. Correct, right? So with this is going to drag the electron density and I'll be getting C double bond C plus and this is O minus. Now you only tell me here it is polar in nature. So this gets positive, this gets negative charge. Now tell me, because of this positive charge, carbon, it is electron deficient, which will go and attack nucleophiles will go and attack. Correct? Because of this positive charge, carbonyl groups are going to show nucleophilic addition reaction. This is okay? Justified? Done. Now let us go to the next question. In case 2, what is case 2 or case 1? Rather, case 1 I have taken the students, case 2, alkenes rather. So, ethylenic double bond. Ethylenic double bond means it is C double bond, C double bond. So, in ethylenic double bond, C double bond, C, what they gave here, you understand, in this case, is it polar? There is no electronegativity difference. No electronegativity difference because both are same atoms. So, no polarity. No polarity. When there is no polarity, only tell me there's no requirement of any nucleophile attacking. Correct? So, you see this bond breaks, electrophile comes and attacks and it undergoes electrophilic addition reaction. Not nuclear. You see? So, in this case, there is no electronegativity difference, no polarity. So, because of the presence of double bond, electrophile will come and attack. The electrophilic addition reactions. In this case, nucleophilic addition reaction because of polar bond. Because of polar bond. So easy, very easy. Next question, students. Carboxylic acid groups, but carboxylic acids contain carbonyl group, but do not show nucleophilic addition reactions like aldehydes and ketones. Why? They contain carbonyl group exactly, but they do not show nucleophilic addition. First of all, let us see the solution. Carboxylic acid group is this COH, right? Now I am writing double bond here. Now count the number of electrons 1, 2, 3, 4, 5, 6, 7, 8. Because of the presence of double bond, it shows resonance, right? Yes. When it shows resonance, what will happen? This one, the shift drops here and this drops here. What do you get? R, C, oxygen minus because the bond has shifted to oxygen, double bond, oxygen because it has lost a pair of electrons because of the formation of double bond and hydrogen. Okay, this is your resonating structures. Now you tell me, because of the resonance, the partial positive charge on carbon is reduced or no? Because this is shifted, carbon positive charge is reduced. Yes, let us write that. Because of resonance, partial positive charge on carbonyl carbon atom is reduced. Okay. And what will happen if it is reduced? Yes. In this case, when it is reduced, will nucleophile go and attack? Already excess electrons are there on the carbon atom, means on the oxygen atom, on the top. Right side, when it sees there is a double bond. Correct? Right? Keep it here. Now I'll go to, I don't have place. Very bad. Very bad. My team, I'm going to scold them. So, but in this case of aldehydes, when you see the resonance in this way, here, case of carbonyl, this is more electronegative. So, this part gets positive charge, this part gets negative charge. Now, you only tell me, in aldehydes and ketones, there is a resonance hybrid, but here there is a deficiency on carbon atom. Here, because of resonance, there is no deficiency created. So, the carbonyl carbon is less electrophilic than this. Compared to this carbon, this is less electrophilic. That's why nucleophile addition reactions or whatever nucleophile has to attack, will it go first to aldehydes or will it go first to to acids? So because this is less electrophilic compared to the carbon in aldehydes and ketones, nucleophilic addition reactions of aldehydes and this one aldehydes and ketones do not take place much. Correct, na? Yes. So, but here compared to this and this, which one will go faster, students? Yes, you only tell me which is the requirement. Carboxylic acids. The carboxylic acids do not show, but do not show the nucleophilic addition reactions because there is no requirement in this. Here, there is requirement because it is already negative. You'll write like this. Because of resonance, partial positive charge on carbonyl carbon atom is reduced and and is less electrophilic. Because of this less electrophilic nature, NAR are not shown. Okay, NAR are not shown. Next question. Identify the compounds A, B, C in the following reaction. CH3Br, Mg ether, A. I have to find this, I have to find this, I have to find this. Okay. First is what, students? It is nothing but Grignard's reagent. So here addition reaction will happen. All right. Then you're adding carbon dioxide and water. That means I have a clue here. To that particular thing, there is a formation of acid, the carbon dioxide. And after that, I took methanol. Okay, methanol and sulfuric acid. That means this is compulsory an esterification reaction. So I'm going to get ester here. With this reagents only, I can say what it is. Chala, let's start the reaction. First of all, I'm taking CH3Br. What is this compound? Methyl bromide. You need to label it, students, otherwise you'll not get marks. To this, what are you adding? You're adding magnesium in the presence of dry ether or ether. Dry ether. Addition reactions, this goes and adds to this. I get CH3 Mg. What is this? This is methyl magnesium. Write completely, I'm not writing here. Bromide. What is this? This is compound A. So this, what did we do? We have added carbon dioxide and we have added water. Now this completely goes and adds to this. Yes, we have studied, right? Magnesium bromide, MgOH, After that you do hydrolysis, the bond breaks and I'm directly writing the compound. I get acetic acid. Remember, no, students, OH goes and adds here, H goes and adds here, and you're adding carbon dioxide. So further it gets converted to, what is this compound? This is ethanoic acid. This is B. Then to this ethanoic acid, we are further taking ethanol and acidic medium. Correct? Alcohol in the presence of sulfuric acid. What is this reaction? This is esterification reaction. So acid combines with one more this methanol to form an ester. What is this compound? This compound is methyl ethanoate. Methyl ethanoate. Smaller group comes. No, the parent chain. Parent chain goes with the larger atom, right? Eth. The parent group goes with the larger atom eth, and then the substituent methyl. So methyl ethanoate. So this is compound. Got it? So they asked me what A is right here, students. You have to write in the end. A is what? Yes, CH3 MgBr. Write the complete name. How I did here. Please write the complete name there. Methyl magnesium bromide. This B means B is ethanoic acid. What is C? C is methyl ethanoate. So right, they'll give you marks, full marks. Chala, next question. Next question. Why are carboxylic acids more acidic than alcohols or phenols, although all of them have hydrogen atom attached to oxygen atom? Okay. First of all, carboxylic acids are more acidic than alcohols or phenols. Okay. What is the difference between phenols and carboxylic acids? And listen, let us start writing. When do I call something as acidic? When something donates proton or H plus ions, right? In aqueous solutions. In case of carboxylic acid, when I break it, I'm going to get minus plus H plus, correct? Let us take alcohol now. I'm going to take this RO and H plus. In case of phenols, when I cleave a phenol compound, it breaks and forms a phenoxide ion instead. All right. So in case of phenol, what is going to happen? It's going to break in this term. O minus and H plus. Correct, right? Now let us write the resonance hybrids for all. All right. So in case one, again students, again I'm getting a call. Sorry. All right. Let's come back to the question, students. All right. I just finished the call. Sorry for that. So now we have written the release of protons. Now let us see the resonance hybrids for all. Why are we writing resonance hybrids? Because we will see which is more stable, so that further proceeding would be easy. When I write the resonance hybrid of carboxylic acid, see here, this is your carboxylic acid negative charge, this is your carboxylic acid negative charge, and okay, this is the resonance hybrid of carboxylic acid. Now when I take phenoxide ion, this is your phenoxide ion. Sorry, my circle is a little bit. In case of phenoxide ion, what we take, resonance hybrid, I am representing in this case here. And this is your O with negative charge. Okay, so this is your, now this is not the negative charge of the resonance hybrid. Then in case of the first compound, that is your, that is the second compound, that is phenol, there is no resonance. So no resonance in case of alcohol, correct? Now no resonance in alcohol. Right. Now, first of all, you understand resonance hybrids in carboxylic acid, phenoxide. In phenoxide also, if I have to check, okay. So now let us reason it. The electron charge in the carboxylic acid, where is it dispersed here? The charge is more dispersed. It is right. Charge is more dispersed in this, right? Correct. Now, second thing, compared to this is more dispersed, all right. And in this case, how many electronegative atoms are there? There are two electronegative atoms, correct? Na? Yes, there are two electronegative oxygen atoms. Oxygen atoms, right? And then what happens? In this case, there is only one electronegative oxygen atom. Electronegative oxygen atom. So in this, when I compare both of them, which is more stable compared to both your phenoxide and this? So here both are trying to drag the electron density. In this case, phenoxide. In other words, carboxylate ion is relatively more stable compared to phenate ion. Correct? No, this is more stable because the electron density is shifting between both. Right? So when this is more stable, H plus ion releasing H plus from carboxylic acid, is it easy? Yes. First, it is distributed, carboxylic ion more stable as compared to phenoxide. That is, I accept. But the release of H plus ion from carboxylic acid is easier because in this case, you're seeing The resonating structures are resonating inside the ring. So from here, this is dragging, this proton is released. This is dragging, the proton is released. That means because the charge is more dispersed, because there are two oxygen atoms in electronegative, pull is more, pull is more. That's why H plus release is easy. Easily I can release H plus. Correct? So you're going to come back and write carboxylic acids are more, or carboxylic acids are more acidic than phenols. Then phenols are more acidic than alcohol. Done? That's done. Sure. Next, let us go to the next question. Next question, right? Complete the following sequence. They're asking you complete the following sequence. First think, what is the students? Grignard's reagent, okay, addition and hydrolysis. Then sodium metal, okay, right. Then they've given me alkyl halide. Okay, chalo, easy question, students. Let us do this. First of all, let us take your ketones. CH3, C double bond O, CH3. What is the name of this compound? This is propan 2-one. Okay. This, what are you adding? You're adding Grignard's reagent CH3 MgBr, and you're doing further hydrolysis, SHOH. So this whole compound goes and adds here, and further hydrolysis, ketones are getting converted to your alcohols, because hydrolysis also we did and MgOHBr is out. What is the name of this compound? This is 2-methyl propan 2-all. Okay. Now, to this we are introducing sodium metal. Metal, when you introduce, you will be getting butoxides, because this is but, CH3COOH and ONA, O minus Na. This is what? Sodium tertiary butoxide. Now you are introducing CH3Br. What is this reaction, students? Alkoxide plus alkyl halide. This is Williamson's synthesis. Williamson's synthesis. Correct now? Right. Now, what do you get? You're going to get a compound which is nothing but this. What is the name of this compound? This is nothing but 2-methoxy, 2-methyl propane, 2-methoxy propane. That's it. That's it. So this is your reaction. They asked me what are the products formed. So let us write what is A, what is B, and what is C. A is 2-methyl propan to all. What is B? B is the butoxide part. Sodium tertiary oxide. What is C? C is 2-methyl, 2-methyl, 2-methoxy, not 2-methyl. Is 2-methoxy, 2-methoxy, 2-methyl propane. Methoxy, 2-methyl. Done. This is a question. Let us read the next question, students. Hope this is clear. Let us read. What happens when benzene diazonium chloride is treated with water? Okay, benzene diazonium chloride. So let us write. So first of all, benzene diazonium chloride is heated with hot water, they said. Okay. BDC. So BDC formula, first of all, BDC, how will you take it or how will you get it? All right. So, can anybody answer this question to me? Can anyone tell me what is the answer? What is the product formed of the students? I'll give you a clue for this. First of all, BDC with hot water, when you take one acetyl chloride is added in that. Okay, acetyl chloride, that compound is added. So check and tell me this answer in the comment section. Okay, so I'm waiting for your answer. Shall I give you one more clue for this? Okay, so here when this BDC is added, see, we normally we take BDC, a lot of compounds with BDC, where BDC forms with copper chloride, BDC forms with CuBr, BDC forms with different compounds. It forms different products. So you tell me what is the hot water forms. One more thing also I can give you. Hot water, cold water, there is one compound which forms with which is acidic. Okay. Shall I only write it, students? Okay. Shall I'll only do it. Try to confuse you all. Well, BDC I'm taking. That is nothing but N2Cl because time is less for you all. With water, I get compound, which is nothing but compound, right? Plus nitrogen gases out plus HCl. Okay. So, and ma'am, you said acetyl chloride. What is that? All right. This is a small clue inside that. I'll let you know further. All right. Chalo. This page is blank. Next page is blank. Okay. Next page. Let us go to the next. Can Gatterman Koch synthesis, Koch reaction, can it be considered a similar Gatterman Koch reaction be considered similar to Friedel-Crafts acylation discuss? That is what they're asking. Okay. Gatterman Koch. What is Gatterman Koch first of all? Let us write. Is both similar? They're asking. Gatterman Koch reaction. Gatterman Koch reaction is what? Basically, you're taking benzene, you're adding CO plus HCl. This is nothing but HCOCl. You're adding what? Anhydrous AlCl3, the presence of CuCl2. What is it forming? It is forming benzaldehyde, BHO, and this is forming HCl. Correct? Now, Friedel-Crafts acylation they asked. So, second reaction is Friedel-Crafts acylation reaction. Okay. What is this? This benzene ring, your acyl group. You're taking anhydrous AlCl3, double bond O, acylation, and HCl. Okay. So first of all, they're asking me, can it be considered compared to since both are same or not? So first of all, you understand Gatterman-Koch synthesis is what is it? This particular reaction is called formylation. That means you're introducing a CHO group. This is formylation. Formylation is nothing but introducing CHO group into the ring. Okay. Friedel-Crafts acylation group is introducing RCO group. You're adding RCO group to this. That's the difference. Second thing is in Friedel-Crafts acylation reactions, here you're treating with Lewis acid anhydrous AlCl3. Yes, it's treated with an acid. It means it is treated with an acid chloride. So this is an acid chloride, correct? Because RCOH is a parent atom. Here you're treating with acid chloride in the presence of anhydrous AlCl. Here also you're treating with an acid chloride. This is also acid chloride, correct? Again you're treating with anhydrous AlCl. That means in both the cases you're treating with acid chloride and anhydrous AlCl3. That's why, can I make it similar? Yes. So you can write Gatterman Koch synthesis and Friedel-Crafts acylation reaction can be considered similar due to reaction of benzene with acid chloride and anhydrous Al3. That's all. Simple. 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 Chalo. Next question, long answer type questions. So for this long answer type question, students, as I said, I'm going to send this long answer type questions and one more surprise which I'm going to tell you just now. I'm going to send you 235 MCQs. See, long answer type, you have big case-based questions. This long answer type questions, then this long answer type questions. Like this, I'm going to send you more and more students in your Telegram. So, students, along with long answer type questions plus 238 MCQs, your complete chapter will be done. Yes, study this. Please study this. As I said, for aldehydes, point number one, please study handwritten notes. Handwritten notes. Done. After that, you are going to study. What are you going to study? You're going to study last minute series. After this, you're going to study this complete 238 MCQ. This your chapter will be over. Thank you so much for watching. I'm sending this in your Telegram channel. Telegram channel. So please join the Telegram. Telegram link is in description. Is in description. Okay, students. Bye. See you with the next video. Take care. Bye.